Hello class. This recording is for chapter 10 of your ER book, the Enhanced Entity Relationship Model chapter 10. For this chapter, I'm not going to be using the slides. I'm going to ask you to please get your book and also get the notes which I have posted on ER diagrams, on EER diagrams, the Enhanced Entity Relationship Diagrams. I've called these notes pages 1 through 8, and they are basically figures, and I would like you to get a copy of those figures and have that ready in front of you. So if you don't have those figures which are posted on e-learning, again the figures are called pages 1 to 8. And if you don't have your book, would you please pause this recording right here and get your figures and your book. Once again, the figures are on e-learning. Okay, now that you have your figures and your book, I'll start talking about the chapter 10. Well, chapter 10 is actually an extension of the entity relationship diagram, and that's why it's called Enhanced Entity Relationship Diagram. Well, the abbreviation for that is EER, Enhanced or Extended Entity Relationship Diagrams. So rather than calling them ER diagrams, we're now going to call them EER diagrams. Okay, the idea of the EER diagrams. I'm going to start with the figures. So if you look at figure 4.1 or page 1 of pages 1 through 8 that were posted on e-learning, you will see the figure has an employee on the top, and then you'll see secretary, technician, and engineer. Now, so far we referred to an entity. We referred to an entity, so we would have an employee entity. Now we are going to start referring to an entity class. So an employee would be an entity class. So you would have a class full of employees, and of these employees, some may be secretaries, some may be technicians, some may be engineers, some may be managers. And the employees may be salaried or hourly. So basically, we have a class full of employees rather than one employee. We have a class full of employees. So now we are looking at the main entity, which we are going to call the super class or the generalization class. So employee would be the super class or the generalization, and the subclasses would be the secretary, the technician, or the engineer. So we have a super class called employee, and we have a subclass called a secretary or a technician or an engineer. Okay, so we basically take up the whole big class employee and break it up into secretary, technician, or an engineer. Now, what does the D in the circle mean? The D that kind of branches out into the secretary, technician, or engineer. The D means disjoint. So that means an employee may be a secretary, maybe a technician, or an engineer, but cannot be both a secretary and technician, or cannot be both a secretary and engineer. So you can only belong to one of the subclasses. So the D for disjoint means that the employee could either be a secretary or a technician or an engineer, but could not be more than one of those. Now, an employee can also be a manager. There is no D or anything else there, so an employee may be a manager. So in effect, we can say that the same employee may be a secretary as well as manager. There's nothing stopping us from thinking that. At the same time, the manager may not even be one of those secretary, technicians, or engineers. Because as you notice, there is not a double line between the employee and the D. So that means not all employees are secretaries, technicians, or engineers. Some may be managers. So not all employees are secretaries, technicians, or engineers. So secretary is a subclass of employee, technician is a subclass of employee, engineer is a subclass of employee. The secretary, the technician, or the engineer is what's called a specialization. Typically, every specialization class would have at least one attribute that distinguishes it from the other class. So for example, here we have typing speed for the secretary, a T grade for the technician. The typing speed for the secretary would be the attribute that distinguishes it from the technician. The technician would not have a typing speed. And this, likewise, the secretary would not have an engineering type. So we don't repeat the attributes like first name, last name, middle name on the secretary or the technician or the engineer because the subclasses would inherit from the employee superclass. So this is a superclass-subclass relationship where the subclasses inherit from the superclass. So we do not have to put those attributes in the subclasses because they inherit from the superclass. Now, employee may also be a manager, and a manager may manage a project, and a project may be managed by a manager. Okay, an employee must be either salaried or hourly. So that means all the employees in that set must be either salaried or hourly. And notice the subset symbol or the arrow, kind of the C kind of arrow pointing downwards. The C kind of arrow shows which is the subclass. So in this case, the secretary is a subclass, technician is a subclass, engineer is a subclass, salaried employee is a subclass, hourly employee is a subclass, and so forth. Okay, so turning to page 2, or figure 4.2 of pages 1 through 8, we just show instances of an employee, secretary, engineer, or technician. So an employee may be a secretary or an employee may be an engineer. So E1 is a secretary. Notice this was a disjoint relationship on the previous page. So E1 can only be a secretary, cannot be both a secretary and an engineer. E2 is an engineer, E3 is a technician, and so forth. Okay, turning over the page, we have on figure 4.3, we have another example of a vehicle which must be either a car or a truck. So the vehicle again is a superclass, and the car or the truck are the subclasses. So the vehicle ID does not have to go on the car because that's a subclass. So every vehicle must be a car or a truck, and that is because of the double lines between the vehicle and the D. The D again shows the disjoint relationship. So a vehicle is either a car or a truck, but it cannot be both a car and a truck. Okay, going to figure 4.5, which is right below figure 4.3, we have a part must be, that is a double line, although it might look rather fainted. A part must be either manufactured or purchased. And according to this diagram, it can be both manufactured and purchased. The O in the circle in place of the D, or instead of the D, the O in the circle means an overlap relationship. So that means that the part could be both, could be either or, so it could be manufactured, or it could be purchased, or it could be both manufactured and purchased. Once again, the manufactured part is a specialization, and part is the generalization or the superclass. And manufactured part or purchased part is the subclass. Okay, turning over to figure 4.6 on page 4, we have an employee, may be a secretary, technician, or engineer. An employee may be a manager. Employee must be hourly or salaried. And then we have an engineering manager. So we have a lattice here. We have what's called a subclass lattice. or a specialization ladder, okay, where the subclass leads to another subclass or class, okay. So an engineering manager inherits from an engineer, from a manager, as well as salaried employees. Okay, turning over to figure 4.7, we have a person must be either an employee, alumni, or student, but can also be both an employee and student at the same time, or maybe an employee and alumni at the same time. Notice the O between the person and the employee, and so it's an overlap relationship. An employee, however, must be either a staff, faculty, or student assistant. So an employee can only be one of the three categories and not more than one of the three categories. A student assistant must be either a research assistant or a teaching assistant. Again, every subclass has to have at least one attribute that distinguishes it from every other class. Okay, so a student must be either a graduate student or an undergraduate student. The student assistant is inheriting from both the employee as well as the student. Okay, now I'm going to take a moment to go back to your book now. And I'm going to ask you to turn to page 260, where we have shown an example of an athlete. An athlete may be a tennis player, a golfer, or a football player. But an athlete could also be a tennis player and a football player. Again, the same idea, that is an overlap constraint. Turning to page 261 in the book, figure 10.4, the furniture must be either a table, desk, or chair, but cannot be both a table and a desk. Okay, now, the mapping rules. So if you will turn to page 264 in your book, we have where we start the mapping rules. And actually, I created this table 10.1 to kind of give you a summary of when which mapping rule would really be the best. Okay, so like I said, mapping rule 15 would create multiple relations, but would work best with the total or participation, total or partial participation, disjoint or overlap relationship. So this works either with total or partial participation, and works either with disjoint or overlap relationships. Mapping rule 16 would again create multiple relations, but this works with disjoint relationships and total participation. Mapping rule 17, on the other hand, creates a single relation, but works best only with disjoint relationships and can be total or partial participation, and when not many attributes are on the specialization, and when there's a single type attribute. So I've given you the criteria of when which mapping rule works best. In a way, you can use any of the four mapping rules, but some mapping rules will work better than others in certain situations. And again, the reason for that is to reduce redundancy. Now, I'm not going to go through every single mapping rule here, but I'm going to let you go through that on your own. For example, on page 265, we have mapping rule 15, and this mapping rule says mapping generalizations and specializations with disjoint or overlap subclasses with total or partial participation. So for each generalization or specialization entity situation, create one relation for the generalization entity and create one relation for each specialization. Add the attribute of each entity to the respective relations. Include the primary key of the generalization in the specialization relations. The primary key of the specialization relation will be the same as the primary key of the generalization relation. Okay, and the following page, page 266, actually starting from page 265 going on to page 266, I've given you examples of mapping rule 15. And then I go on to mapping rule 16, 17, and 18, and I'm going to kind of let you read those mapping rules on your own just because they really are pretty much in detail. And I'm sure you're going to be able to follow them once you read them. They're pretty straightforward, so that should not be a problem. Okay, so going to figure 10.5, we have again a specialization hierarchy where we have an athlete, maybe a tennis, golfer, or football player, but the football player may be playing for a hobby or professionally. Okay, we show figure 10.6, we show a specialization lattice where we have a shared subclass. So looking on the bottom part of the diagram, the professional football player is a shared subclass because it is inheriting from both the football player as well as the professional football player. So that's what we call a shared subclass. Mapping Rule 19 talks about mapping shared subclasses, and I've given examples about that again. So that is a specialization or a shared subclass. Okay, now I'm going to ask you to go back to pages 1 through 8, the pages that you printed off e-learning, and look at figure 4.9. Okay, I hope you have figure 4.9 in front of you now. And I want to introduce the concept, or rather I'm going to skip over figure 4.9 and I'm going to go over to figure 4.8 and come back to figure 4.9 later. I think it'll be easier to explain the concept through figure 4.8. So we have the concept of a union. Notice in the little circle now, we do not have a D or an O, we have a U. The U means a union. Okay, what is the difference between a D and an O? Well, one was a disjoint and one was an overlap. But when we have a D or an O in the circle, we have a relationship between a superclass, like employee, and the subclasses of technician, engineer, or what did we have there? We're going to forget the third category. We had a secretary, technician, and engineer. So the superclass was the employee, and the subclass was the secretary, technician, and engineer. The subclass. So this was a superclass, subclass relationship. When we have a union, all the entities involved are really superclasses. There's no superclass-subclass relationship. There's a relationship between superclasses. So, the person's a superclass. I'm on figure 4.8 off your pages 1 through 8. Person is a superclass, bank is a superclass, company is a superclass. Owner is a superclass. So every one of those are superclasses. And so the way the English goes is the owner may be a person, a bank, or a company, or maybe both a person and a bank, or maybe both a bank and a company, or the owner may be a person, bank, and company, or company. Okay, so you can be one of the three, or you can be two of the three, or you can be three of the three. So the owner really can inherit from one of the three, two of the three, or three of the three, but the owner, although the owner inherits, the owner is still a superclass. That is the difference in concept between a union and a disjoint and overlap. Okay. Again, in a disjoint and overlap, we have a scenario of a superclass-subclass. In the union, we have a scenario of only superclasses inheriting from each other. Okay, so looking at the bottom part of the figure, we have a registered vehicle, which may be a car or a truck. From the English, you would not be able to tell if that was a union. The only way you would be able to tell is if you know that the car or the truck were superclass entities. Then you know that it should be a union. So going back to figure 4.9 now, which is really page 6, you have figure A, you have a union relationship. So in this case, on figure A, the company and the person are superclasses, but account holder is also superclass, inheriting It could inherit from either the company or the person or from both. And the account holder has an account at the bank. Okay, looking at figure B, you have the property could be inheriting from the building of the lot, or could be inheriting from both the building of the lot. But the building is a superclass, the lot is a superclass, and the property is a superclass. But in the second part of the figure, we have property on top, and the property must be a building or a lot. So in the second figure, when the property is on top, the property is the only superclass, and building and lot are subclasses inheriting from property. So again, how do we determine if a relationship is an O or a D or a U? It's an O or a D if it's a superclass subclass kind of relationship, and it's a U if all the entities are superclasses. So going back to your book, page 274, section 10.8, we have categories or union types. So we have a player, which may be a student or a faculty, or could be both a student or a faculty. So in this case, the student is a superclass, faculty is a superclass, and player is also a superclass. So turning to page 276, figure 10.7, we just have a full participation between the faculty and the player. So every faculty has to be a player, basically. And figure 10.8, I give you a scenario of a category or a union type, and I can't remember if I mentioned, a union type is also called a category, where the superclasses or union type with different primary keys. Okay, so in figure 10.7, the student and the faculty both have the same primary key, SSN. And in figure 10.8, primary insurance, patient, and other responsible party have different primary keys. So you could either have the superclasses having the same primary key, or the superclasses could have different primary keys. And figure 10.8 on page 278 is just a figure where the payer must be either one of the primary insurance, patient, or other responsible party, or could be two of the three, or could be three of the three. And the next thing I presented was the mapping rules, okay, for mapping when you have the different primary keys. Okay, again, I think the mapping rule when the superclasses have the same primary keys is mapping rule 20. The mapping rule 21 is when the categories superclasses have different primary keys. Okay, then I'm going to ask you to go back to pages 1 through 8 of the diagram you printed on e-learning, from e-learning, and look at figure 4.10, which is the last figure. And the last figure is really nothing but just a complex figure. So we have a person who may be a faculty or a student, and the student could be a graduate assistant, and the graduate assistant, the research instructor could be inheriting from the graduate assistant or the faculty, and so forth. And I'm just going to ask you to look at that diagram, spend some time and think about it and read it. It's kind of a good diagram because it kind of gives you an example of what I would expect in your project, gives you an idea because there's one-to-one relationships, end-to-end relationships, the D relationship, the disjoint, and then there's the union relationship. There is no O or overlap relationship, but I will require one of those in your project. So that basically is just a more complicated EER diagram. And in the book, I've gone through pretty much in probably as detailed as I could in terms of the mapping rules and in which scenario it would be best to pick up on which mapping rule. And I think I've covered all the bases on that. So I'm going to actually, it would be a good idea for you to read the book in detail. And there are a lot of different scenarios, so it's like you have to read it pretty slowly in order to digest it and think about the different scenarios. But the one thing is you're going to need this chapter a lot, very much for the project, so make sure you understand it. The main thing to understand, I know people do not have a problem understanding the overlap and the disjoint relationship, but oftentimes I get questions on the union relationship. And once again, to recap that, when you have a superclass and there are subclasses, like there's the employee superclass and there's the subclass of a secretary, technician, or engineer, that is either a disjoint or an overlap. But when you have all superclasses involved in the relationship, then that's when you use a union. Okay, with this I hope I have explained the concept in detail and explained it further. And I will end this lecture right now. And if you have any questions, I would suggest you listen to the lecture over again and read the book. Bye now.